In this video, we are going to derive the derivative of the arctangent of x. So pretty much the derivative of the arctangent of x. Now, we may not know the derivative of the arctangent of x, but we do know the derivative of the tangent of x. So, what we're going to say is, we're going to say that y is equal to the arctangent of x. If this is true, then that means that x is equal to the tangent of y. And so what we've pretty much done is, we've pretty much gotten rid of arctangent of x from the picture. And so all we have to do now is take the derivative of both sides with respect to x, and then just solve for dy over dx, because that will be the derivative of the arctangent of x. So that's what we're going to do, okay? So we're going to take the derivative of both sides of this equation with respect to x. Okay, so this is pretty much what we're doing. So we're going to evaluate the left side of this equation, and we know that the derivative of x is just going to be 1. So this is just 1. The derivative of the tangent of y, we know the derivative of the tangent of y is just going to be the secant squared of y, right? But this isn't all, because we're taking the derivative of this with respect to x, right? So what that means is we have to use the chain rule, right? So what that means is we're going to have to multiply by the derivative of y with respect to x, right? Because this is the chain rule, and we have to do that. So multiply by the derivative of y with respect to x. And so this is pretty much what we have. Okay, so now that we have this, all we're going to do now is we're going to solve for dy over dx. And so dy over dx equals 1 over the secant squared of y, right? So this is what dy over dx equals. And so all we have to do now is we have to pretty much substitute y for something in terms of x. And it turns out that we have something actually right here where we pretty much have what y is in terms of x. Y equals the arctangent of x. But that will just make things more complicated, right? If we substitute y into here, it's going to be like secant squared of the arctangent of x, and that's just going to, we could do it, but it's just way more complicated. We actually have a way easier way to do this. What we could do is, well, notice how we're doing the secant of y. We could think of that as just the secant of an angle, right? Because we could treat y as an angle, and we're taking the secant of that angle, right? And so pretty much what that means is we can treat y as an angle of a right triangle. And so what we're going to do is we're going to draw a right triangle right here. Right? So this right here is our right triangle. And we're going to say that this angle right here is angle y. Right? So now that we have this, what this pretty much means is, in order to find the secant of y, we need to know all three of these side lengths. Or we need to know these side lengths in order to find the secant of y. So how can we find any of these side lengths of the triangle? Turns out we already have the answer to that question. Because if you notice right here, we know that the tangent of y is equal to x over 1. And this is all we need to fill in the sides of this triangle. So the tangent of y is opposite over adjacent. So x over 1 is just going to be x over 1, right? Opposite over adjacent. And so now that we have that, we pretty much have the ability to find this side as well. Because this is just going to be, all we have to do is use the Pythagorean theorem for these two sides, and we get the square root of 1 plus x squared. So now that we have that, since we have all these three sides, we have the ability to find the secant squared of y. And so, remember, this is just the same thing as saying 1 over the secant of y, whatever the secant of y is, and then just squaring it, right? That's the whole thing that we're doing. So dy over dx is equal to 1 over, right? We're taking the secant of y and squaring it. And to find the secant of y, that's hypotenuse over adjacent. So pretty much it's just going to be hypotenuse over adjacent, so we get square root of 1 plus x squared. So that's what this is going to be. And so what we're going to get is we're going to get, when we take this and square it, the square root's going to go away, and we're left with 1 plus x squared. And that is it. So this is what dy over dx is. So this is the derivative of the arctangent of x. So this is it. We have now found the derivative of the arctangent of x. That's it.